Okay, so this is the independent t-test lab. So you should have done the single sample t-test, and then this one is the independent t-test, and then our next one is repeated measures t-test. And the independent t-test really seeks to compare the means of two independent samples. And samples can be considered independent if there's no relationship between them. Generally speaking, this means that each participant provides data for only one sample or sample group. And the two groups being compared should be independent of each other. Observations are independent when information about one is unrelated to the other. Now keep in mind that normally this means that one group of participants provides data for the one sample, and a different group of participants provides data for the other sample. And individuals in one group are not matched with individuals in the second group. And so when I said last week we did single sample T, and this lab we're doing independent T, and the next lab is repeated measures T or match sample. That's when we start matching the groups. But for right now, they have to be independent. The scores should be normally distributed, but the t-test is a really robust test, and this analysis can handle violations of the assumption of a normal distribution. The two samples should, however, have the same-ish variance. The dependent variable must be measured on an interval or ratio scale, and the independent variable should only have two discrete levels. So the SPSS file that we're going to use for this one is the sample one from like lab 2 or 3, like a long time ago. So this should look really familiar. And the one variable and the grouping variable represents the value of the independent variable, and the grouping variable should have two distinct values. You can sometimes use 0 for control group and 1 for experimental group. The second variable represents the dependent variable, such as scores on a test. Okay, so how we're going to run this analysis is you go up to Analyze, you go down to Compare Means, and the third one down should be Independent Sample t-test. So the test variable that we want to use is final grade. So we're going to put that over into that little box. And the grouping variable, the one that we're going to look at for the distinct values, if you will, is if they're a morning person or not. So I'm going to put that over here in the grouping variable. Now, you see here there's like two little question marks, so I need to define the groups. So in mine, right, so if you think back to our labs, we gave them a 0 if they were not a morning person, and we gave them a number, or we assigned them a number of 1 if they were a morning person. You can double check the options. It should say 95% confidence, and then click OK to run the analysis. So your output window should look something like this. So with the dummy data that I had here, I had 9 people that said no, they're not a morning person, and 6 people say yes, they were a morning person. Now the mean is the average of their scores, their final grade in that class. So we had a T obtained equaling 0.429 with a significance, though, of 0.675. So we have to fail to reject the null hypothesis, meaning that there really isn't that big of a difference in the average final score for students who say they are or are not a morning person. Now, if this T value was greater than the significance value, then we'd say yes, there is statistical significantly large enough difference between these two groups that for whatever reason one of these was different, right? The morning person or the not morning person, like, wow, that variable really made an impact on their overall final grade. But you can see that we have 9 students that that said no, they weren't a morning person. They have an average score of 86, and then 6 that said yes, they were a morning person, and they had an average score of 84. There is a difference, but not a statistically significant difference. Okay, so for this lab, what I want you to do is I want you to run the analysis just like I did. So make the grouping statistics the final grade, and the if they're a morning person or not, and use the variable of final grade. Now, for the second part, so the first screenshot should give me the output window for like these two things, right? So if you want to take a screenshot and go like that. Okay, so then close out of that one after you take your screenshot. And then what I want you to do next, I want you to pick one other one to analyze, right? So you're going to go down to compare means, independent sample t-test again. Now this one I want you to take morning person and put it away because we're not using that one anymore, but you can use any of these other variables that you want to say, I wonder if, I don't know, the fact they work outside of going to school, if that has a factor on it, or the day of the class, or the class time, right? So let's click outside employment. So you're still going to have to define your groups. So I think we had for outside employment was, let's see here, outside employment, yeah, so part-time or none at all. So we have, yeah, 0 is none at all, and 1 was part-time. So now our grouping variable is going to be, did they have an outside job? And the t-test was 1.239 and the significance level was 0.23. So yes, having a job or not impacts it. So let's take a look here. So if they don't have a job outside of taking their class, right, they have an average score. So some people said they had that, an average score of 88.57. 8 people said, well, yes, they had a job. It was part-time while they were going to school, and they had a group average of 83. That's statistically significantly different. That's a lot there, right? So pick one. You don't have to pick final grade. Like I said, you can pick, a different one. You can pick, class time or day of class, but take a screenshot of that one too. So for this lab, I want 2 screenshots. All right, awesome. Thanks.